In Chapter 4, Section 2, we're going to continue the California State Standard number 3, working with polynomials. Before we prepare for multiplying polynomials, we'll need to be familiar with multiplying monomials. And in that case, we want to refresh your memory or reintroduce you to using laws of exponents. So we have three properties of exponents we're going to deal with. First, the fine print. A and B represent real numbers. M and N represent positive integers. If that's true, then any number raised to the m power times that same base raised to the n power is the same as that base raised to the sum of the exponents m plus n. So in other words, when we're multiplying and the bases are the same, do not change the base, add the exponents. Another property is if we have a product, a times b, and we're raising that to the m power. Instead of multiplying the product first and then raising it to a power, we can take each factor a, raise it to the m power, take the other factor b, raise it to the m power, and then multiply later. So in this particular scenario, rather than multiplying first and raising it to the power, we can raise each factor to the power and then take the product later. And then if we have any base raised to a power, and that whole quantity is in turn raised to another power, you have a base raised to a power raised to a power, you keep the base, do not change it, and you multiply the exponents m times n. So it's important that you differentiate when you add the exponents and when you multiply the exponents. All right, with those properties in mind, we're going to look at some numerical examples to try to reinforce our learning. So here's two monomials that we're going to be multiplying. We're going to be multiplying negative 7 a squared b to the fourth times another monomial 3 times a b to the fifth. And in this case, what we're going to do is start out with the numerical coefficients. Negative 7 times positive 3 is negative 21. Then a squared times a to the first, we're going to keep the base a and add the exponents 2 plus 1, which leaves me with a to the third. Then with the b's, b to the fourth times b to the fifth, we're not going to change the base b, we're going to keep it and add the exponents 4 plus 5 and end up with b to the ninth power. Let's look at our next example. We've got x, y squared, that quantity raised to the fourth power. According to the property we just learned, we can take x and raise it to the fourth power. So that's x to the fourth. And then we can take y squared and raise that to the fourth power. And when we have a base raised to a power raised to another power, then we multiply the exponents, and 2 times 4 is 8. So again, we're just practicing some simple numerical examples of our laws of exponents. This is really negative 1 times y squared to the fifth power. When we take negative 1 and raise it to the fifth power, that's negative 1 times itself 5 times. And we'll come back and simplify that in a second. Now we're going to take y squared and raise that to the fifth power. And coming back to the negative 1, when you multiply a negative number times itself an odd number of times, your answer is going to stay negative. If it was an even number of times, it would be positive. And then y squared to the fifth, when you have a base raised to a power raised to another power, you multiply the powers, and 2 times 5 gives you y to the 10th. All right, continuing along with another numerical example, we're going to simplify three monomials being multiplied. X squared times x to the fourth, that quantity squared, times x to the first. Let's do this base raised to a power raised to another power first. So x to the fourth, that quantity squared, we multiply our exponents. 4 times 2 is 8. Now we're multiplying. The bases are the same. We're going to keep the base. Do not change it. It's going to stay x. And we're going to add the exponents, the 2 plus the 8 plus the 1 that we didn't write down when we write x. It means x to the first. And simplifying that, 2 plus 8 is 10, plus 1 more is x to the 11th. All right, let's look at another one. We have a monomial, that quantity being squared. So what we're going to do is we're going to take the constant and square it. We're going to take the a and to the first and square that, which is a squared. We're going to take the b cubed and square that. We're going to take the c squared and square that. Simplifying, 4 squared is 16. A squared stays a squared. You have a base raised to a power, raised to a power. You multiply the exponents, so 3 times 2 is 6. And then another base raised to a power, which in turn is raised to a power, so you multiply 2 times 2 is 4. And that's our answer, our monomial 16a squared b to the 6th c to the 4th power. All right, our last example simplifying and practicing these exponents is actually multiplying a monomial times a polynomial. And yes, we've done this with numerical coefficients, and yes, we know this is the distributive property. 2x squared has to be multiplied by every term of the polynomial. So 2 times 1 is 2. X to the second times x to the third, and I'm doing this in my head. I'm keeping the x, adding the 2 plus 3 to get 5. Next term, negative 3 times 2 is negative 6. X squared times x squared, we keep the x, add the exponents, 2 plus 2, which is 4. The next term is going to give me 2 times 4, which is 8. X squared times x to the first, we keep the x and add the exponents. 2 plus 1 is 3. And then my last term, negative 1 times 2x squared is negative 2x squared. I check to see if there's any like terms. There's not. And I check to see that my polynomial is in descending powers of x, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd. And we've distributed out a monomial times a polynomial and simplified our answer. And that's our first look at multiplying monomials and a monomial times a polynomial. And please remember those 3 laws of exponents.